Okay, so we're reviewing right now a 9.1 radians in degrees. So the first question is, if a circle has a radius of 1, what is the circumference? Well, the circumference of a circle is measured by circumference is equal to 2r pi, or pi d, or d times pi, where r is equal to the radius and d is equal to the diameter. So when you plug this in, the radius of being 1, we get that the circumference is 2 pi. Thus, the circumference of the circle, 2 pi, is represented by 360 degrees. Why does a circle have 360 degrees? Listen to the following video. Hey guys, so I know that all of you are probably wondering, why, Ms. Taylor, does a circle have 360 degrees? Well, I'm here to answer your question. So if you look here at this circle, imagine that this were the sun. And by the way, I'm going way, way back in time. So think about the sun, and I want you to then also think about the earth. And think about how many days are in a year. 365, sometimes like this year, 366 days. So imagine if this is January 1st. So what ancient philosophers, mathematicians, whatever they used to do, they would think about this and say, okay, this is January 1st, and as the Earth is rotating, it's rotating in a circular-like way around the sun. This, of course, is being the sun. So they thought, 365, we could say that a circle has about 365. Now, they knew that, you might be wondering, why am I saying 365 and not the whole 360? Well, they knew that a circle, or rather that a year, had more than 360 days. But the nice thing about the number 360 is that it divides much nicer than the number 365. It has way more factors, and thus we're able to carve up our circle in this particular fashion and in others. Okay, so now let's move on to the next slide. Hey guys, so not quite. Okay, so can angles be measured with a less arbitrary means? Sorry about the typos. I'll correct that in the PowerPoint version. And yes, you can create something that's less arbitrary than 360 more or less days in a year. So a radian is an angle measure where the angle creates an arc that is 1 radius long. A radian is thus a radius angle. Radii and ang make radian. 360 degrees is equal to 2 pi, and by that logic, 180 degrees is equal to pi. When we have no symbol, the angle is in radians, so be careful to put the degree symbol whenever you mean degrees. How to convert degrees to radians? Here's an example. Let's convert 135 degrees to radians. Now, since 180 degrees and pi represent a semicircle, it can be said that semicircle divided by semicircle is the same as pi divided by 180 degrees, which also simplifies to be 1. Therefore, 135 degrees times pi radians divided by 180. When we simplify that, the degrees go away, and we get 135 pi divided by 180. You don't have to write the words radians. I'm just putting here so that you see which unit we're working with. So now you're going to simplify this. And the greatest common factor that they both have is 45, and this simplifies to be 3 pi over 4 radians. Now, how do we convert radians to degrees? Well, you take 5 pi, an example is taking 5 pi divided by 6 radians to degrees. So again, since 180 and pi, they both represent a semicircle, it can be said that a semicircle divided by a semicircle, or 180 degrees divided by pi, they're both equivalent to multiplying by 1 when you divide both of them. Therefore, 5 pi radians divided by 6 times 180 divided by pi. Notice how you have a radian in the numerator and a radian in the denominator. We do that in order for the radians to cancel out. So when this happens, we get 180 degrees times 5 divided by 6, which simplifies to be 150 degrees. Oop, that's supposed to say degrees, not radians. I'll correct that. Now, how do we also convert radians to degrees? Here's another example. So let's say we have to convert 6 radians to degrees. Since 180 degrees and pi represent a semicircle, we can also state that this is like multiplying by 1 when you multiply 180 divided by pi. Therefore, 6 radians times 180 degrees over pi radians simplifies to be 6 times 180 divided by pi. Notice here that pi is a number. Its presence does not mean that your answer is still in radians. A radian value does not have to have pi, or all values that have pi in it does not necessarily mean that it's a radian measure. So the unit circle is a circle with a radius of 1 unit. The initial side of an angle is the starting side, and it is always positive along the x-axis. An angle is a measurement of rotation, counterclockwise about a circle. The terminal side of an angle is the ending side. So notice here, we start on our initial side. Our x-axis, the positive side of our x-axis, is always the initial side. And here, it's carved up, we've carved up our unit circle by increments of 45 degrees. In this next slide, we're going to carve up our unit circle by 30 degrees. And you can also, if you wanted to, divide it by 60 degrees, counting every 60 degrees. And if you'll notice, the unit circle, if it is anything, it is symmetric. So the first video here discusses the slides, discusses how we derive the 100, how we derive the degrees for 360 degrees. So I'm going to skip that slide, and I'm going to go next, though, to the one that shows us how we derive radian measures from these listed degrees. Okay, so now that we have derived the degrees that go around the unit circle, let's see how we can convert those to radians. So as you'll recall from the previous slides, a unit circle has a circumference of 2 pi because each radii is worth 1. So 0 or 2 pi, 0 at the start, 2 pi at the finish. So if you go halfway around, half of 2 pi is simply pi. And if you do half of that, that's pi over 2. So if this is worth half a pi, 2 halves pi, or pi, 3 halves pi, or 4 halves pi, which is the same as 2 pi. Now, what's a half of a half? Well, it's a quarter. So we're going to call that one pi over 4. So now we're going to count the quarters. 0 quarters, 1 quarter, 2 quarters or 1 half, 3 quarters, 4 quarters or pi, 5 quarters, 6/4, or 3/2. And 7/4, or 7 pi over 4. And 8/4, which is the same as 2 pi. So now, connect that. So now, let's look at what this could be worth. What is this portion worth? So I'm going to compare this to 30 degrees. So this will compare to 30, and I know that 180 compares with pi because they're both semicircles. So now 30 is a sixth of 180. So this portion here will be a sixth of pi. So now I'm going to count all the way around. I'm going to count each sixth. So this is 0/6, 1/6, 2/6, which is the same as 1/3, 3/6, which is a half, 4/6, which is the same as 2/3 pi, 5/6, 6/6, which is the same as pi, 7/6, 8/6, which reduces to 4 pi over 3, 9/6, which is 3/2, 10/6, which is the same as 5 pi over 3, and 11/6. And then we have 12/6, which is the same as 2 pi. Notice here how 5/6, it's close to a whole, but it's not quite. Think of pi as a whole. So it's close to a whole, but not quite. 3/4, it's close to a whole, but not quite. 2/3, close to a whole, but not quite. Right now, I'm just discussing the number relationships for the numbers in front of pi. However, look at 7/6. It's just past a whole. So notice here that in the third quadrant, we're just past a whole pi. So this is 5/6, and this is 4/3. So all of these, just a little more than a whole of a pi. And here, these are just shy of 2 pi. Notice the number relationship. You're doubling your denominator minus 1. So these are close to 2, but not quite, with the exclusion of the pi's. I'm not discussing the pi's, I'm just discussing the whole numbers that we see. Okay, so now let's move on to the next slide. Okay,